Hey guys, Smikket here. Welcome to the first video of my algebra tutorial series. This video covers a very fundamental and basic part of algebra, and that would be the real number system, and operations with numbers. We're going to cover 5 concepts in this tutorial. I'll try to infuse this video with maximum knowledge while being quick and to the point. So let's get started. Okay, so let's go ahead and take a look at these number sets I have over here. You guys, any of these 5 things that I have listed out here is going to be considered a real number, okay? That's going to be important. Remember that really a real number is pretty much any sort of number that can exist except for an imaginary number. And that is actually a real thing in math, but don't worry about it. Okay, so guys, what is a natural number? You can think of a natural number as something that can be found in nature. Surprise, surprise. So you could have 1 apple, you could have 2 apples, you could have 3 million apples. You could physically have those. But can you physically have 0 apples? No, you cannot. That doesn't make sense. If you don't have an apple, you don't count -3 apples because, you're supposed to have 3 apples. No, you just don't have any apples. So natural numbers are going to be 1, 2, 3, and everything behind those. Okay, guys? So let's move on to the whole numbers. What are the whole numbers? Whole numbers are exactly like natural numbers, except we add in the 0. And that is all you need to remember for whole numbers, okay? So I'm going to put 0, 1, 2, 3, etc. Alright, so let's move on to the integers. An integer is going to be 0, 1, 2, 3, etc., etc., but it also goes the other way. So this includes negative numbers now. So let's go ahead and write those down. So it's going to be everything less than -3, -2, -1, 0, 1, 2, 3, etc. That's all that integers are. Rational numbers are going to be a little bit different than integers. A rational number can be negative or positive. It can't be 0 though. And a rational number can also has to be a fraction or a decimal. So I'll put a few examples down here for you guys. And then I'll do 0.25. because that actually equals 1/4. I'm just doing random rational numbers here. Hopefully you guys get the idea. Okay, so that leaves us with just one more. Irrational numbers. I'm sure you've heard of pi by now in this time of your life, unless you're like 4 years old. There's a good chance you might not have heard of it. But pi is 3.14159, etc., 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 infinity. That is an irrational number, guys. And if you look at pi, it embodies an irrational number so well because it goes on forever, but the numbers 0.14159, those never repeat in any sort of pattern that we can observe. So they're definitely irrational. Those are infinite, non-repeating pattern numbers. They're crazy. Pi. So I'll write that down. Pi. And also, if you're familiar with e, it's basically another thing just like pi. It's an irrational number. If you're not familiar with e, don't worry about it. Just think of irrational number as pi. Okay, guys. So let's go ahead, now that we know the number sets and how to identify what real numbers are and different types of real numbers, let's jump into the properties of real numbers. That's going to be something called the commutative property, the associative property, identity property, multiplicative inverse property. So let's move on to that. So, first off, the commutative property. With the commutative property, I'm going to be using 3 different numbers, and we'll call them A, B, and C. These can be anything, as long as they're real numbers. So, with the commutative property, all it's saying is A plus B equals B plus A. And honestly, guys, that's pretty simple. I feel like the name is more confusing than the actual concept. So if we said 1 for A and 2 for B, we can easily find that this is true. This basically just says it doesn't matter what order you add things, at least in this specific situation. This is the most basic example of the commutative property. Just to go ahead and really sink that in, 3 does equal 3. The commutative property is true. Okay, guys? So just remember that. So let's move on to the associative property, which is a little bit more complex, but really not that much different. But before we do that, I apologize, guys. We've got to look at one more example of the commutative property. The first one was with addition. The second one will be with multiplication. And that is basically the same thing, except with multiplication. A times B equals B times A. Yes, 1 times 2 does equal 2 times 1. 2 does equal 2. Okay, guys, so we can also use the commutative property for multiplication. Now let's go to the associative property. How I like to look at the associative property is that here on the left side, we've got A all by itself. But B plus C, they're in parentheses. They are associates. But that doesn't really matter, because over here, A plus B, those are associates in the parentheses, and C is all by itself. But let's go ahead and plug in the numbers that we did for the last one. 1 plus 2, and for simplicity, I'll make C equal 3, equals 1 plus 2 in parentheses, plus this lonely 3. Okay, so we'll do the parentheses first, because of the order of operations. Inside is going to equal 5 plus 1. And inside of here, 1 plus 2 is going to equal 3 plus 3. And 1 plus 5 equals 6. 3 plus 3 equals 6. Alright, so this is the first part of the associative property, the addition part. Now, let's look at the very similar multiplication aspect of the associative property. Okay, so it is the exact same things, except notice that I've swapped out the plus signs for these little dots, the multiplication signs. So let's go ahead and test this one out. You've got 1 times 2 times 3, which equals, according to the associative property, 1 times 2 times 3. So 2 times 3 in here is going to equal 6 times 1, which equals, in here, we're going to have 2 times 3, 6 equals 6. Okay, guys, so it doesn't matter which variables associate with each other. As long as they all get multiplied, the associative property tells us that it's going to be the same. Okay, let's move on to identity, which is a lot easier in my opinion. So the identity property is telling us that if we have A plus 0, that's going to equal 0 plus A, which really just equals A, because 0 is 0. So I'll go ahead and do a real-world example. Well, not a real-world example, something with numbers. So we've got 1 plus 0 equals 0 plus 1 equals 1. And yes, 1 plus 0 is 1. 0 plus 1 is 1. And yes, 1 is 1. And that is all the identity property is saying, you guys, at least for addition. Now, the identity properties for multiplication are a lot similar, except I'm going to do multiplication, and instead of 0, I'll do 1. So A times 1 equals, let's see here, 1 times A, which equals A. Okay, so 1 times 1 equals 1, times 1 equals 1, equals 1. Okay, guys, so that's basically just saying anything times 1 is itself. And you probably already knew that. It's just good to know that that's the identity property. So for inverse, I'm going to go ahead and ditch the a, b, and c and just use something that looks a lot like this. 5 plus x equals 0. And all the inverse property is saying for addition is that, hey, we've got 5 over here. The inverse of 5 is going to be whatever makes this equation equal to 0. Okay, so what is the inverse? Well, if we have 5 minus 5, that definitely does equal 0. So that shows us that there is an inverse for this number 5. Hopefully that makes sense to you guys. I think that's a pretty easy concept. If not, apologize, complain in the comments. Okay, so let's look at the multiplication side of this, and then we've got one more thing to go through, and we will be done. Just stick with me, guys. Okay, so this is the multiplication side of the inverse property. Here we see that a times 1 over a equals 1 over a times a, which really just equals 1. And all that's saying is that, let's pretend that we just write a over 1, which we can do that with any number, that's fine. And let's see. A over 1 times a does equal a over a, which any number that is over itself in a fraction, the numerator and the denominator are the same, that's always going to equal 1. And just for the sake of time, I'm not going to go too in-depth about that. Hopefully that makes sense to you guys. You know, 2 over 1 times 1 over 2 equals 2 over 2, which does indeed equal 1. And you know what, guys? I'm going to save the last thing, the distributive property, for another video. Thank you guys so much for watching. I really hope it helped. Subscribe, like, share my videos. Thanks so much, guys. Adios.